Hello everyone. So in today's lecture, we are going to discuss about Kuhn-Tucker's method of optimization of multivariable functions. Okay. So in the previous lecture, we discussed about the Lagrange's method that was used to optimize the multivariable function that have equality constraint. Right. So your Lagrange's method is used when we have equality constraint, while your Kuhn-Tucker's method is used when in the multivariable function the constraints are of inequality type. Okay, so when we have constraints of nature greater or equal to or less than equal to, these constraints comes under inequality, right? So these type of if these type of constraints are there, then your Kuhn-Tucker's method is used for the optimization. Okay, so if you remember in Lagrange's, when we did numericals, the constraints were of equality nature, right? That is 3x plus 4y equal to 32, right? Likewise, again, the constraint were of equality nature, right? So when we have equality as our constraint, then for optimization of those multivariable function, we use Lagrange's method. If the nature of constraint is inequality, then we are going to use Kuhn-Tucker's method for optimization. All right. So in this method, what happens is that first of all, we use lambdas to include the constraint values, and then the first derivative is find out, and then certain regular conditions are satisfied. The conditions are these. So first of all, just like we used to do in Lagrange's method, the equation is formed using lambda as our term, right? So and the partial derivative of that is find out based upon the variables that are involved in the multivariable function, right? After this, certain other cases are included, that is delta j into gj equal to 0, gj is less than equal to 0, and lambda j is greater or equal to 0. Right, these depends upon the type of constraint that we have. So if we have the constraint of like greater or equal to 0, then instead of less than equal to 0, we will have greater or equal to 0, and the lambda to be greater or equal to 0 or less than equal to 0 depends upon if you are going for the minimization or maximization and type of constraint that we have. Okay, so if you are going for the minimization, right, if you want to minimize a function and the constraints are of nature greater or equal to, right, so in those cases the condition for lambda will be that lambda should be less than equal to 0. If you are going for minimization and our constraint is of nature less than equal to 0, then the lambda that will be condition for the lambda that will be used will be lambda j equal to greater or equal to 0. If you're going for maximization, then this constraint, if you're going for maximization and the constraint is greater or equal to 0 nature, then the lambda that will be used or the condition for the lambda that will be used will be delta j greater or equal to 0. If we are going for maximization and our constraint is of less than equal to 0, then our lambdas will be less than equal to 0 condition will be used, right? So the care should be taken to use the desired condition for lambda, otherwise the solution that we will get will be of erroneous nature. Okay, so let us do a question for better understanding, like how this Kuhn-Tucker method is used for the optimization of multivariable function containing inequality constraint, right? So we have function f equal to x1 square plus x2 square plus 60x1, and this function have two inequality constraint, that is x1 minus 80 is greater or equal to 0 and x1 plus x2 minus 120 greater or equal to 0. Okay, so let's solve the question. So first of all, we will apply the Kuhn-Tucker's condition, right? So for that, first of all, we have to form the equation and have to partially differentiate with the number of variables that we have in our function value. Okay, so let's say first of all let's form the equation. Let's say the equation is k, and it will have x1, x2, lambda 1 and lambda 2. Okay, because we have two constraints, that is why we are using lambda 1 and lambda 2. If we had more than if we had another constraint, then we would have used lambda 3. All right, so the equation will be x1 square plus x2 square plus 60 x1 plus lambda 1 x1 minus 80 plus lambda 2 x1 plus x2 minus 120. Okay, so we have formed the equation. Now we have to apply the conditions, right? So first of all we will partially differentiate it with the number of variables that we have, that is x1 and x2 in the function that was given to us, and then apply these cases. Okay, so let's apply the Kuhn-Tucker's condition. So your Kuhn-Tucker's condition is given by, so we will first of all use case A. Case A, your case A is this one. This is your case A, right? So we will partially differentiate our equation with respect to the variable that the function has. So partially differentiating first of all with respect to x1. So we will have 2x1, right, plus 60, then plus lambda 1 and plus lambda 2. We'll put it equal to 0, and let's say this is equation number 1. Then partially differentiating with respect to x2. So we will have 2x2 plus, this term will be 0 because it does not contain any x2 variable. Here we will have lambda 2, right? Let's put it equal to 0 and name it equation number 2. Okay, let's name it equation number 2. All right, so this is our case A. Okay, the second case is lambda j gj equal to 0, right? This is our case B. Okay, so lambda j gj, that is j is 1 2 3, that is lambda 1 for constraint 1, lambda 2 for constraint 2. Okay, so let's form case 2 or case B. Okay, so that is lambda j gj is equals to 0. So we will have lambda 1 with constraint 1. Constraint 1 is this one, g1, x1 minus 80 equal to 0. x1 minus 80 is equals to 0. Then we have lambda 2. The second constraint is this one, that is x1 plus x2 minus 120 will be equal to 0. x1 plus x2 minus 120 will be equal to 0. All right, so let's name it equation number 3. This will be equation number 4. Okay, let's name 1 and this will be 2. All right, then we'll go for case C. All right, and case C, this is your case C, that is gj less than equal to 0. It depends upon the condition. For taking this as an example, we considered our constraint to be less than equal to 0. In the question we have greater or equal to 0, right? So we are going to use this one only. So case C, Gj, so that will be, this will be equal to, our constraints are of greater or equal to nature, so we'll write x1 minus 80 greater or equal to 0, and x1 plus x2 minus 120 greater or equal to 0. Okay, so this is equation number 5, this is equation number 6, right? Then our case D. All right, so our case D, this is the situation number D, right? That is lambda j greater or equal to 0. This depends upon the condition that we have, right? So the question says that we have to minimize, right? The question says we have to minimize, so we will refer here, right? We are going to minimize. Then the question say the constraints are of nature greater or equal to, right? Constraints are of nature greater or equal to. So since it is of nature greater or equal to, then we are going to use lambda j to be lambda j less than equal to 0, right? So here we are going to write lambda j less than equal to 0. That is, our lambda 1 should be less than equal to 0, our lambda 2 should be less than equal to 0. This is equation number 7 and this is equation number 8. Okay, so we have these equations, and through this we are going to find out the value of x1 and x2. All right, so that is our ultimate aim, to find out the value of x1 and x2 so that the function is minimized. All right, so for this we have to solve these equations, right? So what we'll do is, let's say we will take up the equation number 3. Okay, we'll take up the equation number 3. So from equation number 3, from equation 3, what is equation 3? Equation 3 is lambda 1 x1 minus 80 equal to 0. Lambda 1 x1 minus 80 is equals to 0, right? This is our equation 3. So from this we have either our lambda 1 is equal to 0 or our x1 minus 80 is equal to 0, right? From this equation we have these two cases, right? So to make this relationship to be true, we have these two conditions, right? So let us first of all take lambda 1 equal to 0 and assess and try to find out the value of x1 and x2 and see if all these conditions, right from 1 to equation number 1 to equation number 8, are satisfied or not, right? So basically what we have to do, we have formed these 8 equations. We are going to find out the value of x1, x2, lambda 1, lambda 2, and these values should be such that all these relations, that is equation, right from equation number 1 to equation number 8, should be satisfied. If and when these values are satisfied, then that point will give us the desired minima, right? So let's take lambda 1 equal to 0 first and assess. Okay, so we are going to take case 1, case 1. Okay, our case 1 is lambda 1 is equal to 0. Now let's put this value in equation 1 and 2. Okay, let's put this value in equation 1 and equation 2. Okay, so putting the value of lambda 1 in equation 1 and equation 2, right? Let's put the value in equation 1 and equation 2. So let's put it. So our equation is 2x1 plus 60 plus lambda 1 plus lambda 2 equal to 0. Putting lambda 1 equal to 0 here, right? And since we do not have the value of lambda 1 in equation number 2, so we will get the value of lambda 2, right? So if you see, so we can find out the value of x1 and x2 in terms of lambda 2, right? So let's find this. So we have 2x1 plus 60 plus lambda 2 equal to 0. Okay, so my x1 will be minus lambda 2 divided by 2 minus 30. Okay, putting the value of lambda 1 in equation number 2, we'll get the value of x2, right? So x2 will be minus lambda 2 by 2. Okay, so you see we have the value of x1 and x2. Okay, now let's put this value in one of these relationship, right? And since your equation number 4 has all these values, so let's put the value of x1 x2 in equation number 4 so that we can get the value of lambda 2. All right, so putting the values of x1 and x2 in equation 4, our equation 4 is lambda 2 x1 plus x2 minus 120. Okay, let's put the values. We have lambda 2, instead of x1 we'll put minus lambda 2 by 2 minus 30, and instead of x2 we'll put minus lambda 2 by 2. Okay, minus lambda 2 by 2 minus 30 minus lambda 2 by 2, then we have minus 120. So we'll put minus 120, this is equal to 0, right? So upon solving, right, we will have the value of lambda 2 to be 0 or minus 150. Okay, so we will have the value of lambda 2 to be 0 or minus 150. All right, so you see we have taken the value of lambda 1 equal to 0. Through this we have found out the value of lambda 2. Okay, so now we have value of lambda 1 and we have value of lambda 2, right? So let's take since we are in the case 1, so lambda 1 will be 0, and let's check by taking lambda 2 equal to 0 or for once time, and then lambda 2 equal to minus 150 the second time, right? If lambda 1 and lambda 2 satisfy the desired all these the value of x1 x2 x3 obtained by taking value as lambda 1 equal to 0 and lambda 2 equal to 0, if they satisfy the equation number 1 to equation number 8, then all good, we need not to take minus 150. If lambda 1 equal to 0, lambda 2 equal to 0 do not satisfy, we'll check for minus 150 also. All right, so first of all let us consider lambda 2 equal to 0. Automatically lambda 1 is 0, right? But I will write down lambda 1 equal to 0 since because we are in the case 1, right? That is we are taking the lambda 1 equal to 0. Okay, so we have lambda 2 equal to 0, lambda 1 equal to 0, and we will put it in equation number, we will put it in equation number 1. Okay, so if we put it in equation number 1, we will get the value of x1, right? Likewise, if we put the value of lambda 2 in equation number 2, we will get the value of x2. Let's do it. In equation 1, okay, so the equation number 1 is 2x1 plus 60 plus lambda 1 plus lambda 2, right? Lambda 1 is 0, lambda 2 is also 0, right? So through this our value of x1 will be minus 30, and here the value of x2 will be 0, right? So let me put the values. So that will be 2x1 plus 60 plus 0 is equals to 0. So x1 is minus 30, equation 1 and equation 2. And equation 2, that is 2x2 plus 0 will be equal to 0. So x2 will be equal to 0. So we have x1 equals to minus 30 and x2 equal to 0. This is the our value. Let's check the rest of the conditions, since we have used equation number 1, 2, 3 and 4, right? So needless to say, these conditions are fulfilled, right? Let's check equation 5, 6, 7, 8, that if these our values are satisfying or not. Okay, so talking about the value of lambda, the lambda should be less than equal to 0. Lambda 1 and lambda 2 should be less than equal to 0. Our value of lambda 1 and lambda 2 are 0. So these conditions are fulfilled. Okay, now let's check for equation number 5. Equation number 5 says that x1 minus 80 should be greater or equal to 0. Our x1 is minus 30. Minus 30 minus 80 will be equal to minus 110, which is not greater or equal to 0, right? So we can say that condition for equation number 5 is not satisfied, right? So the value of x1 to be minus 30 and x2 to be 0 we cannot take, right? Because we have to satisfy right from equation number 1 to equation number 8. All these parameters need to be satisfied. Okay, so the value of x1 and x2 violates criteria C equation 5, right? Criteria C or case C equation 5. This is not satisfied, so these are not the value, right? Hence, let me write down case only to avoid any confusion. Hence, rejecting this point. Hence, rejecting the points, right? We are going to reject these points, right? So this is not the points, right? So we will reject this. Now let us check for lambda 2 to be minus 150. Okay, consider lambda 2 to be minus 150, and of course we are in the case 1. Remember, we are in the case 1, so automatically lambda 1 is equal to 0. So lambda 1 is equals to 0. Okay, so again putting this value in equation number 1, putting the values in equation 1. Okay, we are going to put the values in equation number 1. These are our equation number 1 and 2. Okay, so let's put the values. So we'll have 2x1 plus 60. Lambda 1 is 0, so we'll put it 0. Lambda 2 is minus 150 and will be equal to 0. So through this we'll get the value of x1 to be 45. All right. The equation number 2 is 2x2. We don't have any lambda 1 variable, so we need not to put the value. Then we have minus 150, that is equal to 0. So our x2 x2 will be 75. X2 will be 75. So our x1 point is 45, x2 is 75, right? So again, let us check among the conditions that we have. So again, checking in the conditions. So of course, our lambda2 value is minus 50, right? So it is satisfying condition number 8 or the equation number 8. Our lambda1 value is 0. Again, we have less than or equal to 0, right? So this is also satisfied. Our equation number 5 says that x1 minus 80 should be greater or equal to 0. Okay. Our x1 is 45. So 45 minus 80, again a negative value, right? So again, the case C, equation number 5 is not being satisfied, right? So we are going to write the same statement. Okay. The values violates case C, equation 5, hence rejecting the points. Okay, we are going to reject the points. Okay, so you see, case 1, lambda1 to be 0 does not satisfy the cases, right? Case right from 1, equation number 1 to equation number 8. Okay, so let's adopt this parameter, that is, or this relationship, that is x1 minus 80 is equals to 0. Okay, we'll take this and see. So this was our case 1, so we'll take this as our case 2. All right. All right. So we'll take case 2, and case 2 is, that is, x1 minus 80 is equals to 0. Okay, so from this we have x1 is equals to 80. Okay, so let us put the values in equation 1 and 2. Putting value in equation 1 and equation 2. Okay, putting the value in equation 1 and equation 2. Oh. I copied the wrong slides. Okay, so let me just quickly do this. Okay, so putting these values in equation 1 and equation 2, we have equations as, so if we put these values, so of course we will get the values in the form of lambda1 and lambda2. Okay, so quickly let's do it. So put in equation 1 and equation 2, so we will have the equation is 2x1, so 2 into 80, 2 into x1, that is 80, right, plus 60 plus lambda1 plus lambda2 plus lambda1 plus lambda2 equal to 0. So from this we will have 160 plus 60 plus lambda1 plus lambda2 equal to 0. So if you see in equation number 2, in equation number 2 we have lambda 2, right? So it's better to find out the values in terms of lambda 2. All right, so we'll have lambda 2 to be minus 220 minus lambda 1, right? Let's put it equation number 9. Okay, then putting the values in equation number 2, we have 2x2. Let's put the value of lambda 2 minus 220 minus lambda 1 is equals to 0. So from this we'll have the value of lambda 1 to be 2x2 minus 220. Okay, so this is our value of lambda 1, right? So let's put the value of lambda 1 in equation number 9. So putting the value of lambda 1 in equation 9. Okay, so from that we will have the value of lambda 2 to be minus 220 minus 2x2 plus 220 plus 220. Okay, so our lambda 2 value will be minus 2x2. Okay, let's put it equation number 10. Okay, so now let us put the value of lambda 2 in equation number 4. Okay, so what we are going to do, we are going to put this value in equation number 4, right? Let's just put the values and find out. Putting values of lambda 2 in equation 4. So we'll have equation number 4 as just putting the value minus 2x2, then we have 80 plus x2 minus 120 is equals to 0. Okay, so this is our equation number 4, right? So the value is right. So it will be minus 2x2 x2 minus 40 is equals to 0. All right, so on solving it we'll have two values of x2, right? So the first is x2 is equals to 0 or x2 to be 40, right? So we are working on case number 2, right? And in the case number 2 we have value of x1 to be 80, and now we have two values of x2, that is x2 equal to 0 and x2 equals to 40. Okay, so what we are going to do now, we have value of x1 and x2. So let us find out the value of lambda 1 and see if the value are up to the desired cases. Okay, so let us first of all take x2 equal to 0. Okay, so if we take x2 equal to 0, so in the previous one we have the value or the equation, that is lambda 1 equals to 2x2 minus 220. Okay, so taking x2 equal to 0, our lambda 1 is minus 2 to 0. Okay, our lambda 1 is minus 2 to 0. Okay, and through this the value of lambda 2 will be minus 220 minus of minus 220. So our lambda 2 will be 0. The value of lambda 2 is minus 220 minus lambda 1, minus 220 minus 220. So this will be 0. Okay, so you see we have the value of x1, we have the value of x2, we have the value of lambda 1, we have the value of lambda 2. So let us see if these values satisfy the desired parameters. Since our value that is lambda 2 and lambda 1 should be less than equal to 0, we have minus 220, it is satisfying this parameter. It is lambda 2 is equal to 0, it is satisfying this parameter, right? Now in our equation x1 is 80, right? X1 is 80, so 80 minus 80 is equals to 0, right? So condition number 5 is satisfied, and then we have 80 plus x2. What is the value of x2 that we have? That is 0 minus 120, right? Should be greater or equal to 0, but if you see, the value will be negative, right? It will be minus 40, right? Which means the equation number 6 is not being satisfied, right? It means equation number 6 is not being satisfied. So since equation number 6 is not being satisfied, this means our x2 point does not satisfy these desired conditions. All right, so what we are going to write, point x2 equal to 0, x1 is equals to 80, does not satisfy or violates case, what case? It violates case C, equation 6. Case C, equation 6. Hence rejecting the point. Okay. The next point is x2 equals to 40. So we'll take x2 equals to 40, and through this we'll find out the value of lambda 1 and lambda 2. Okay. So our x1 is 80, x2 is 40, right? And we have the equation, that is lambda 1 is equals to 2x2 minus 220. So 2 into 40 minus 220. Okay, so through this our lambda 1 will come out to be minus 140, right? Lambda 1 will be minus 40. How? 2 into x2, let me just write it down, 2 into 40 minus 220, okay? So this will be minus 140. All right, from this we'll put the value of lambda 1, equation number 9, and through this we'll get the value to be minus 220 minus 140. So this will be minus 360. Okay, so the points are 40 comma 80 comma 40, right? So let's check all the parameters. So again, since the values are less than 0 of lambda 1 and lambda 2, this is satisfied. Our x1 is 80, so 80 minus 80 is equal to 0, so condition number 5 is satisfied. X1 is 80, right? X2 is 40, and you see this will be equal to 0, so equation number 6 is also being satisfied, right? Equation number 6 is also being satisfied. Since the values of x1, x2, lambda 1, lambda 2 are obtained using equation 1, equation 2, equation 3 and equation 4, so of course they are going to satisfy these equations, right? So we need not to check in these, right? So we can say all the cases are being satisfied. So points x1 equal to 80, x2 equals to 40, lambda 1 equal to minus 40, lambda 2 equals to minus 360 satisfies all the points. wait a second. Oh, the value of lambda 2 is lambda 2 minus 2x2, right? So x2 is 40, so here the value of value will be minus 2 into 40, so it will be minus 80. Okay, equation number 10, just for reference I am writing equation number 10, right? Still it is satisfying the case that is lambda 2 equal to 0. Okay, so we can say that point x1 equal to 80, x2 equal to 40, x1 equals to minus 40, and let me just recorrect it. X2 is 2x2, that is it will be minus 2 of x2, which is equals to minus 2 of 40, that is 80, right? So it is satisfying this point. So we can conclude these point minimize the function. Okay, so the point x1 equal to 80, x2 equal to 40, lambda 1 minus 140, and lambda 2 equal to minus 80 satisfy the points. Okay, so this is how the Kuhn-Tucker's method is done. Try to solve it by yourself. Once again, the same question, try to solve it by yourself. If you have any doubt, you can always ask in the comment section. Okay, so that is for today. Thank you.